we move on to fundamental concepts. So fundamental concepts is very essential to learn any new things of an object. If you want to learn anything newly, means we have to know what are the fundamentals behind that. So likewise, first one is a space. Space is a region which extends in all directions and contains everything in it. So this is the space. The position of bodies in space is determined with respect to the reference system. So the time. So these are the fundamental concepts. To define the succession of events, it is not sufficient to indicate their position. The time of event is required. So time is a measure of the succession of events. So the events we can measure in terms of timing. So how fast it will react, how fast it will complete the task. That is the major criteria here. So time is the main concepts to carry over all such things. And matter. So any substance which occupies space, it is made up of atomic molecules. So these are the things we learned in our early classes as a fundamental one. And then here we analyze static force analysis. When the inertia effect due to mass of the machine component or neglect in the analysis of mechanism. So what is inertia effect? So when we apply certain force, the negative or reactive force is acting with respect to the applied force. That is called inertia force, or simply the negative force or reactive force. We have to keep it in mind. Then dynamic force analysis. When the inertia forces are considered in the analysis of the mechanism, that is the dynamic force analysis. So static force analysis means the analysis of force in stationary conditions of the equipment or component. So dynamic force analysis means the object in motion. Generally the machines running frequently. So if we apply certain forces on the component or equipment, we can get some different kind of aspect. It is called dynamic force analysis here. So inertia force. The force equal in magnitude but opposite in direction and collinear with the impressed force producing the acceleration is known as inertia force. If actually force equal in magnitude. So what are the forces we are applying? That force is equal to mass of the component with the acceleration. That is equal to, based on Newton's second law of motion, force is directly proportional to acceleration. So how it will be the proportion? So we need not to allow anything in a proportion, whether it may be directly or indirect, whatever may be. But we need to try to make them into equal. So far, so force is equal to acceleration is in proportionate one. So if you add with the mass, so what will be the mass required to generate this kind of forces or equivalent amount of force applied? Likewise, we have to add some masses. So that's why we call it as F is equal to ma. So here inertia force is equal to, we studied earlier, the negative or reactive forces. So what is the force we are applying? Likewise, it will react immediately. So F is equal to, or simply inertia force equal to minus of ma. So then inertia torque. The inertia torque is an imaginary torque. which when applied upon the rigid body brings it in equilibrium position. It is equal to the accelerating coupling magnitude but opposite in direction. So inertial torque is equal to minus I into alpha. Then D'Alembert principle. So D'Alembert's principle states that the resultant force acting on a body together with the reversed in effective force or inertia force are in equilibrium. That is, summation of force is equal to 0. This is the concept behind D'Alembert's principle. So dynamic analysis in reciprocating engines. The velocity and acceleration of the reciprocating parts of steam engine or internal combustion engine may be determined by graphical method or analytical method. So the graphical method means we have to use drawing concepts. So utilizing drawing concepts, we call it as geometrical method. With the aid of formulas, we can derive the solution. We call it as analytical method. The velocity and acceleration by graphical method may be determined by one of the following constructions. This Klein's construction, and Ritter's constructions, and Bennett construction. So dynamic analysis in reciprocating engine. So analytical method, consider motion of a crank and conducting rod of a reciprocating steam engine as shown. We discussed earlier here the PC which specify the conducting rod, or OC is the crank. So depend upon the rotation of the crank, the conducting rod moves to and fro. So that is called reciprocating motion. The reciprocating motion converted into rotary motion, vice versa, the rotary motion converted into reciprocating motions. These are the concepts frequently we used here. So dynamic analysis in reciprocating engine. Its analytical method. So from the diagram we can specify let OC be the crank and PC be the conducting rod. Let the crank rotates with angular velocity of radian per second, and the crank turns through an angle theta from the inner dead center. We can briefly written as IDC, inner dead center. Let x be the displacement of a reciprocating body P from IDC after time t seconds, so during which the crank has turned through an angle theta. So dynamic analysis in reciprocating engine analytical methods. So length of conducting rod between centers. So R is the rank of radius of crank or crank pin circle. Theta, inclination of crank to the line of stroke PO. N is equal to ratio of length of conducting rod to the radius of the crank. So N is equal to L by R simply. So dynamic analysis in reciprocating engine analytical method. Velocity of the engine. The velocity of the engine is equal to R into 1 minus cos theta plus pi into n into 1 minus cos pi. So this is the velocity of the piston. We can acquire it in dynamic analysis, especially in reciprocating engines. So these are the main things. So we are analyzing the dynamic concepts. So that's why we are consider this much. So So graphical methods, we can have already three methods. This is the analytical method. We can use the formula, we can get solutions in the right way. Okay, so these are the concepts here.